Hello, everyone. In this lesson, we're going to talk about simple sine equations. And if you remember at the beginning of the semester, I mentioned that there are two kinds of statements in mathematics. One is just a statement, and the other one is if statement. So we come to if statement. Okay, so let's first review what we have learn about what is a function. A function is a rule that assigns each input x in the domain exactly one output f of x in the range, right? So we have this concept, right? Notation-wise, you guys are pretty familiar by this time. And the sine function, right? We have graphed the sine function, domain range, it's odd function. We have done all of that. So now, what is the if statement? What is the if statement you're going to see, right? We know sine is a function that takes input, which are angles, which can be any angle, right? Any real number. And the range, we know the range of sine is always between -1 to +1, inclusive. So, and we also know that, so let's recall the definition ARD. Okay, let's recall the definition ARD. Okay, we use ARD to graph sine curve from -2 pi to +2 pi, right? With all that in our background knowledge, right? So let's recall what is ARD once again, right? A is about angle measurement, right? And if we measure, if we measure angles from, it's a counterclockwise measurement, is a positive angle, right? A is about angle measurement. And angle is positive if measured from the standard position standard, S-T-A-N, from standard position counterclockwise is measured counterclockwise. I'm going to put a counterclockwise here, okay? And an angle is measured, is a negative angle if an angle is negative, right? Negative. And an angle is negative, an angle is positive if, there's an if, right? If measured clockwise, not counterclockwise, okay? From the same position, right? We're rather familiar with this angle measurement. And so the input for all of our sine function, cosine, tangent, cotangent, cosecant, secant, the input are all measured in this way. The next one is reference angle, okay? Reference angle, don't forget. Reference angle is the positive acute angle between terminal and the x-axis. Right, we're very familiar with these. We have used them numerous times. We use them to graph, the sine curve. Lastly, the definition. On definition, of course, we set the stage, right? We set a stage. So definition, what is definition? First of all, we specify a point, right? Point x comma y is a point right, means any point on the terminal sides of the angle A, right? And what else? What else requirement about this point? Other than the origin. Other than the origin, so we're gonna write down 0, 0. That's the origin. Okay, so XY is specified, then R is defined. And this definition guarantees that R is always a positive because the point we chose cannot be 0, 0, right? So one of X or Y is not a 0, or both of them are not a 0. So this guarantees R is always a positive under the circumstances. Now we only study sine. Sine of the angle is defined is as Y over R. So now we have done these. We graph the function. We know the blue numbers corresponds to the blue bars, right? We know all of that. So now let's look at our if statement. What is our if statement, right? Simple sine equation means what? Okay, so here it comes. Here it comes. It says if, right? So typically you will see questions like this. Solve for X. Okay, and then you're given something like one simple example. Okay, sine of X equals to 1/2. What does this mean? What does this mean? This is a typical equation you're going to see. Okay, if you look at from the context of sine as a function, right? We talk about sine as a function. It produces a ratio. There's an input. There's an input. And there's an output. And what is the output? Y over R on the stage. Y over R on the stage. So what does this solve for X means? Okay, we're going to use A. Okay, yeah, other literatures, you're going to see X. But here I'm going to use A. Why did I use A? Because I want to be consistent with the A of ARD. Okay, it doesn't matter. It's just a placeholder. Okay, anyway, so what does this mean? The meaning of this statement is that we know the output. Okay, the output is given, which is 1/2. Okay, so meaning the output is given. Okay, our task is to identify all possible inputs such that the output is, to identify all possible inputs such that, okay, sine of A is equals to 1/2. So we know previously when we were graphing the points, we select the input. From input, we find the output. So we get all of these vertical lines, right? Vertical lines. So now we know the output. We want to identify all the possible inputs. How do we do that? Well, there are different ways to do this. There are different ways to do this. But first, we need to understand what is the question. So this is actually typical, right? If we talk about ARD, this is from D because we already know the ratio, right? Which we know the output is from D to A. Okay, so D, let me find my arrow. Where's my arrow? Right here. This is from D to A. Right? As I mentioned, all the tricky questions you're gonna see in this life. Okay, It's either from A to D or D to A. So now we're doing with the if statement, right? If the output is half, this is the if statement, okay? Basically say if the output is half, right? If the output is half, it's an if statement. If sine of an unknown angle is half, okay? Find all possible solutions, okay? So these are the interpretations, all possible solutions. From where, right? The question is find all possible solutions from where? From the domain of sine. What is domain of sine? All real numbers. All real numbers, right? So we're looking for solutions in the domain of sine. And how do we know we are going to have solutions? Well, because half is in the range. So we surely will have solution. But when half is because the output is half, there are two ways to identify this. First of all, we can look at the unit circle, right? Where do we get the blue number that's half? Right? Oh, there's one here, half. There's another one here. So any angle that terminates on these two terminals, this one or next one, right? They both have reference angles, which are the same, right? That's R is used from DRA. So any angle terminates on these two terminals, either one of them, those angles will make a sign of that angle equals to half. It looks like we're going to have an infinite number of solutions. And from the graph we see, right? So if we draw a horizontal line crossing half, horizontal line, so I'm going to use a different color so it doesn't confuse with the blue. Okay, the horizontal line, half, right? And this half crosses at all these points. How many solutions do we have? We have a solution here, we have a solution here, we have a solution here, we have a solution here. And we have many, many more because this curve goes like this indefinitely to negative infinity to positive, from negative infinity to positive infinity. So now, first of all, once we understand the question, we realize there are as many solutions as possible. Now the question is, how do we express those solutions, right? How do we express those solutions? You can see from the curve, we can identify solutions, and from the unit circle, we can identify solutions, and we can use these interchangeably. Okay, so I clean it up. Okay, as we move on to the next screen. Right? Okay. So understand the meaning now. So to solve sine of A equals to half, we know there are infinite number of solutions. So what are they? So this is how DRA come to our rescue. Okay, DRA, because we know the D is half, right? D is half. R is reference angle. We recognize that they are, so let me move down a little bit so I have enough space, right? So we have identified, so from D, from half, we identified there are two terminals. There are two terminals, okay? Not too thick. Okay, there are two terminals. One terminal here, which has a blue number half, which is a sine value equals to half, and another terminal which is also has the same sine value. And these two terminals have the same reference angle. And that's reference angle, of course, is pi over 6, right? Pi over 6. Now, the solution has to be A. And A is always measured from the standard position, right? So on the first terminal, okay, so let me put the solution here. Solutions, right? We have two terminals, right? So I'm going to construct that two terminals. So you're going to see that. We have lots of solutions. So we're going to have two forms of solutions. Hold on. Not here. Okay. Where's my curly? Yes. Okay. So we have two forms. Each terminal has a solution, because once you find the terminal, your angles can be measured any way you want from the standard position, right? So this is a solution. This is a solution, right? And this will be another solution, right? And this will be a solution, right? And you can just keep going. But all of these angles, how do we express them? Well, this is how we express them. It's pi over 6 equals to plus 2k pi. What is 2k pi? K is an integer, right? If k is 0, it's pi over 6, because 2 times 0 times pi is 0. If k equals to 1, you have pi over 6 plus 2 pi. That's the angle. Let me show you what is that angle, okay? Clear drawing, right? For k, oops, my terminal is gone. Terminal is gone, right? I would want that to come back, okay? All right, so when k equals to 1, you have pi over 6 plus 2 pi. What's pi over 6 plus 2 pi? This is pi over 6 plus 2 pi, you go around, boom, that angle. If k equals to -1, what angle do you get? Right, if k equals -1, is pi over 6 minus 2 pi. So you're gonna measure that angle this way, clockwise, right? So this way you get as many angles as possible, okay? So now let's look at the other terminal. The other terminal, remember the angle, the solution are angles. Angles are measured from standard position, counterclockwise or clockwise. So now we have this terminal, right? And this angle is, well, there are many ways to express this angle, right? The simplest way would be 5 pi over 6. 5 pi over 6. And then once again, you can turn around and round as many times as you wish. You can turn around and round as many times as you wish. We don't need that. Okay? So what is 5 pi over 6? Whoops, sorry. 5 pi over 6. 5 pi over 6 is this piece, right? Then you say, can I use -7 pi over 6? Of course you can use that. As long as you express this terminal once and just plus 2k pi, it doesn't matter. So this form of solution is not unique, but we have to specify k. We have to tell the reader what is k. K is any integer. K is any integer. So that's all the solutions to that equation, a simple sine equation. You can see the process, right? From definition, we know the definition is half, right? Sine ratio is half. And we identify the two terminals, which is related to reference angle, and then we just express each one with our solutions. Are there any shorter way to express it? And I think that's it. Right, so from D to R to A, so DRA. So solving if statement, which is a strict sine equations, or in the future, you're going to see cosine equations, is just from D to A, from D to A. Okay. And other examples will be similar. Okay, so I'm drawing these examples from homework. Let's look at another one. Let's look at another one. Okay, let's look at another one. Oh, before we look at another one, I should do this. Okay, I should do this. Okay, so what do we see from the picture? What do we see from the picture, right? What do we see from the picture? We just drew the line, which is half, right? Horizontal line, this is a half because we know the output and we're looking for inputs, right? So we know the output. The output is y equals to half. Y equals to half. We know the output. How do we find the inputs, right? Every point that crosses where it crosses half and crosses the curve, that's the solution, right? So here's the solution, right? There's a solution over here. Okay, there's a solution over here. And there's a solution over here, and there's a solution over there. Okay, now let's look at our solution representation here. Let's look at our solution representation here to see how it is relevant, right? On this point, the input is pi over 6, the output is half. Okay, so I'm going to mark it. Okay, I hope I can mark it nicely. So this part is, let me use the arrow so they get too crowded, right? So this point, oh, that's not very clear, so forgive me. I'm going to use the arrow, right? Use a orange, green color, just make sure it's visible to you. And this point is pi over 6. Okay. And I'm going to write that blue number. I try to be consistent. In the past, we have used orange. Pi over 6 is something that color I use in the classroom, right? Pi over 6.5, right? And this other point, the output is also half, and the input, let me use a green. The input is 5 pi over 6. 5 pi over 6. Now, we know there are many more in either directions, in both directions, as a matter of fact, right? Between this point and that point, what's the difference? What's the difference? Between these two hearts, right? The difference is 2 pi, 2k pi. And between these two hearts, the difference is also 2 pi. Okay, so this is subtracting 2 pi, subtracting 2 pi. If you subtract pi over 6 by 2 pi, you get here. You subtract 2 pi over here, you get this one. 5 pi over 6, subtract 2 pi, you get here. And if you add 2 pi, you'll find you other solutions. So plus k pi minus 2k pi, you're going to get as many solutions as you wish. Okay, I hope that's clear to you. Okay. So either way, if you understand the picture, we understand the unit circle, then no problem. So let's do another special angle case, right? We will consider non-special case for sure, but let's do another example. Let's do another example. Suppose I'm going to have, I think once you understand this piece, right? So if I have root 2 over 2, how about root 2 over 2? That's probably easy peasy, right? If you want to pause the lecture and if you want to pause the lecture, go for it, right? So once again, I'm going to copy these pictures and bring it with us, right? To solve this equation, what do? Right? So this is a solve for A, right? If, this is an if statement again. Same thing. It's same thing. So what are the terminals? Well, you first have to identify the terminals with the blue root 2 over 2, right? Right here, there's a root 2 over 2, and there's another root 2 over 2. Where is it? Right here, right? And we found two terminals, and CRA. And once we have identified these two terminals, the solutions are just waiting for us, right? You identify these two terminals, and you have as many angles as you wish, but every such angle that are solutions to this equation with this if statement, they terminate on either one of the terminals. And there we go, right? So if you want to pause to express your solution, do that, okay? And now suppose you're back. So that solution would be what? Would be, now this time is pi over 4 and 3 pi over 4. 3 pi over 4. Okay, 3 pi over 4. Similar scenario. In the latter situation, if you want to do root 2 over 2, and then you just draw that horizontal line right there, right? This is a horizontal line. This horizontal line, and this horizontal line indicating the output is, y is root 2 over 2. Okay, and we want to identify all possible solutions. So what are they? This time we're going to use a star. There's a 1 here, pi over 4, 3 pi over 4, and you add 2 pi, subtract 2 pi, you get as many as you want. Okay, or adding 2 pi, multiples of 2 pi, or subtracting multiples of 2 pi, you go either way, you get as many solutions as possible. Okay, all right. Now let's try something that's slightly different, right? So I'm going to give you another example. Okay, this other example would be, whoops, let me clean this up. Okay, the other example is still solving for, right? It's still solving for, and we're going to find solutions. But this time, the example I'm going to give you is going to be negative. Yes. Negative root 3 over 2. Negative root 3 over 2. Right? The same scenario. Negative root 3 over 2. Where do we find negative root 3 over 2 on the unit circle? We're looking for the blue number. Oh, they're not on the top. They're in the bottom. Oh, negative root 3 over 2. There's 1 here. There's 1 here. And from definition, from negative root 3 over 2, we have identified the reference angle. Reference angle. There. 2 reference angles. 2 reference angles. And about these 2 reference angles, you have as many solutions as you want. Right? So let's see what do we get now. The solution would be, right? I'm taking my time. If you want to pause and write down your solution and then come back to watch, feel free to do that. Why not, right? So, okay. All right, so this terminal, how do you express this terminal? There's so many ways to express this terminal, right? You can express it as negative pi over 3. And you can also express it 5 pi over 3, right? So there's all these different ways, negative pi over 3. I usually like to use the simplest way to express it, okay? Plus 2k pi, right? How about the other terminal? The other terminal, I can use a negative 2 pi over 3. Negative 2 pi over 3. And can you use other ways to express it? Of course, there's so many ways to express that angle, right? So k is integer once again. So what happens in this case? It's a negative root 3 over 2. So the horizontal line, we're going to draw the horizontal, where's negative root 3 over 2? Right here, right? So this line, right? So these are the solutions. And we can keep going in both directions. We can have as many as possible. So this point is a solution, this point is a solution, that point is a solution, that point is a solution. So what did I use? Negative pi over 3. I used negative pi over 3, which is this piece, negative pi over 3, right? And negative 2 pi over 3. And then you plus 2 pi, you get over here. You plus 2 pi, you get over here. You subtract 2 pi, you get, you know, 2 others on the other side. Okay, as many as you want, as many as you want. Okay, so these are the examples. These are the examples. And I think these 3 examples should be sufficient for you guys to do homework. Okay. Now I'm going to leave a question for you. Okay, right now we have all these special angles. Right, we have all these special angles. How about these? Right? How about solving for these 2 equations? How to solve these? They don't correspond to special. Don't correspond to special angles. What do we do? Right? We still have we certainly still have a DRA situation. Right? We can certainly draw the output is 1/3, even though it's not going to give us a special 1/3. Where's 1/3, right? So 1/3, this is 1. So third is about this much, right? So 1/3, this is 1/3. We got solutions. We got solutions, right? How about negative 3/5? For negative 3/5, we also have solutions, right? Negative 3/5 is probably somewhere approximately, okay? Negative 3/5. You can see the ideas are the same. The only thing that we have trouble with is to identify these points. What is this piece? What is that piece? Right? And surely once we find these 2 pieces, we just plus 2k pi. And that you have to see after we study arc sine. Okay, so study these pictures really carefully, and then you get to see the use of arc sine. Okay, so I'm going to leave this lesson for, after we're done with arc sine. Okay, you can see the ideas are the same. Ideas are the same, right? So until next time, thank you for watching. Okay, I'll leave you with a question. See you next time.